Welcome to this GEODE conversation titled The Future of Geothermal Energy and the Workforce Together. This series is brought to you by GEODE Consortium, which is led by Project Inner Space and the Society of Petroleum Engineers, and funded by the U.S. Department of Energy Geothermal Technologies Office. My name is Diana Acero Aller. I am a researcher at the National Renewable Energy Laboratory, NREL, and I will be the moderator today. So today's show will last 30 minutes, and we encourage all of you to ask questions in the chat during the program. And it's now my pleasure to introduce our guest. So Dr. Rita Esuru Okorafor is an assistant professor at Texas A&M University. Her research focuses on using oil and gas skills and techniques to solve challenges related to low carbon energy technologies, following her 15 years of experience in the oil and gas industry. Dr. Okorafor was an SPE Distinguished Lecturer in 2023 and 2024, and was the GEODE Workforce Development Working Chair. She's an author of several technical papers and US patents, and she's also an author of 2 novels. Welcome, Rita. And we have also Mr. Alan Siner. He is the Geothermal Sector Council Manager at the Competency Alliance, where he engages directly with key industry stakeholders to create skills pathways and learning content in support of the growing geothermal industry. Alan has been awarded with 32 patents, has published 24 papers, and is recognized with 10 plus industry awards, including the SPE Drilling Engineer of the Year, 4 World Oil Awards, and 2 Petroleum Engineering Awards for engineering innovation. So Rita and Alan, welcome to this GEODE conversation episode. Very happy to have you here. And well, let's kick this off with some questions. Um, let's start with talking about training and education alignment. And
Okay.
this question is going for both of you. How well is currently geothermal integrated in education and training programs? What curriculum or experiential learning modifications are needed to prepare all the workers for conventional or emerging technologies in the geothermal industry? Let's start with Rita.
All right. Diana, thank you very much for this question. So in the US, for instance, geothermal has been there for a while. So it means that it has been embedded in the curriculum somewhere. There are several universities that have taught geothermal, especially on the conventional side. But one of the things is, as we move forward with geothermal energy, we're beginning to see advances, new technologies, emerging technologies, which were not originally embedded in our curriculum. The interesting thing is, even if a course doesn't have, or a school doesn't have geothermal, fully a full geothermal curriculum, there are several other courses that can be piggybacked on, or we can learn from, that we could use for the geothermal space. So for instance, a geoscientist, somebody who is learning geology, could apply their skills in geology in geothermal space. Similarly, somebody that is in the oil and gas industry learning about petroleum engineering could take some of their skills to the geothermal space. So what I see is where we're lacking might just be with the emerging technologies, but in terms of the conventional geothermal energy, I think that we are kind of okay. It's just that as it's becoming more widespread, we would need to expand most of this geothermal curriculum beyond the existing universities.
Great. Yes, it's good because definitely we don't need to start from zero completely, right? Like there are some
Exactly.
fundamentals there. Um, Alan.
Well, I'm the person that's probably going to throw a different curve. So, you know, at the end of the day, when I talk to people around Houston, around different states, around different countries, very few people even know what geothermal is. And I kind of start with that statement. And then if you don't know what it is, you're not teaching it in schools. especially whether it's elementary, middle school, it's people graduating, and I talk to people, and the first thing is, what is geothermal? Is that just a hot pool that you go swimming in or something like that? And that's where we, as United States, needs to change things. We need advertisement. We need training. Right now, geothermal is unrepresented in the US for education. It just isn't there. And what little is there is often just a small module. And, I head up a council for a private company in Tulsa, a university. And it took some time just to get one course for geothermal into the curriculum. And one of the problems is, it's accreditation. If you're doing for petroleum engineering and you're developing this, how do you fit this into what we already have or don't have? So here's just some of the opportunities that we should be working on. So is it great out there? Yes. Is the education out there? And I'll tell you, it's very little. I've been working on this for the last 2 years. I've got over 450 documents. And, one of the things when I say documents, training, it's interesting that, and I'll just share this real quick, oil and gas skills fit about between 85 and 90% of all the things you need to know for geothermal. It's there. But we didn't know that, and people aren't really sharing that yet. So this is what I call the great opportunity for us to fix it.
Yeah, I really like how you put it, right? It's an opportunity also to grow some skills there. So following the same topic, training and education, this question for you, Rita. Given that there is a long and somewhat like unpredictable timeline sometimes with geothermal projects specifically, how do you think the workforce development's efforts can remain really agile and aligned with the demand of these timelines?
Great question, Diana. So these long lead times between projects, it makes workforce alignment quite challenging, but it's not something that cannot be worked on. So what I would say is, let's think about the fact that we have skills that are transferable. So if we develop our curriculums or we prepare training such that somebody from a particular industry, the oil and gas, the mining industry, can come back to the geothermal industry when there's, in quote, a boom, that would be one helpful way. Another thing is, small stackable trainings, modular trainings, because the breadth of the geothermal industry, we have the geosciences, but we are having the people that are dealing with the power plants. We have people dealing with the engineering. And so if we have some kind of training where somebody just, understands, let's say, the power plants, okay, it means that when we start those geothermal projects, somebody who has gotten a certification in power plants can come in at that point in time. So I would think that, those modular stackable certificates kind of programs will be helpful. Cross sector trainings as well, interdisciplinary and transferable. And more importantly, having some kind of hands-on, just short apprenticeship-like programs, which would help people to get hands-on skills. Now, if this is something that is going to be quite challenging, we need to think about, virtual ways in which people can actually get those skills, such that when the jobs finally come or those opportunities comes, they are actually ready for hands-on. Because the geothermal industry is more hands-on. We do all the engineering at the back end and the exploration and the geosciences, but when we need to deliver a project, it's really hands-on. So we need to have ways of quickly bridging that gap, which if we cannot do apprenticeship programs on demand, we need to start thinking about what kind of virtual ways can we do that, using technologies like virtual reality to be able to develop people on that so that they can be ready when these jobs come.
Excellent. And I like how you are already touching some of the topics about transferable skills that we will definitely go there.
Okay.
So this is a good time to remind our live audience to post their questions in the chat box for everyone. Please submit your questions. And let's go a little bit to recruiting transitioning workers. So this question is for Alan. In your opinion, what are the main challenges in recruiting workers from, oil and gas or other type of industries we have here in the geothermal industry. We are talking about compensation or location, job security. What other factors? What is your opinion on that?
Yeah, that's a loaded question there. There's a Diana, there's so many different pathways you could take, and that's the beauty of geothermal. There's a lot of great pathways that you can go out there. And I'll just share this one. In the U.S., geothermal, except for some energy we have, especially on the West Coast, it's almost insignificant. And if I look at, say, Europe as an example, 11 to 12% of the population uses some form of geothermal district heating. And in the US, it is 0.1, not 1%, but 0.1%. So how do we get the message out? How do we show the opportunity? And we start thinking about how do we do this at grade schools to start training about it. I've been in front of a council here in Texas where we got in front of a whole county talking about the future of energy. And it was around geothermal. And it was great. And the parents were all excited about it. And these were youngsters. Well, how do we get people that are more grown, people that are getting ready to get out of high school, people that are maybe in college, or people that wanted to get in college, couldn't afford it? There are so many different pathways that we could do this. And this is where I think it's very important. So here's something I'll share with you. All the data that I can see today, if you look at geothermal jobs, it's about 145,000 jobs today. But if we do it right, before the end of this decade, 2030, the evidence says it could grow by sixfold. In other words, we'd be needing at least 1 million people to help develop the geothermal that we're trying to do. And this is amazing. And what people don't realize is how much energy is beneath our feet right here in the United States. There's an MIT study, it's great. It shows that there's an estimate of about 200,000 exajoules of energy. And I had to look up, what is an exajoule? Well, for a lot of people who don't know, it's equivalent to 277 terawatts. Then you start saying, what's a terawatt? Well, here's what I would tell you. It's massive. And just releasing 2% could supply almost 3,000 times the primary energy needed in the United States. And it's clean, all these things. But my point is, if we could get this training out and we do it quickly and we do it with all different types of ways and get certification, which people today, we really don't have certifications for this. This is what can change the world, and it gets people excited. These are the jobs that are out there. And just some of the opportunities I'm mentioning right now of what we could be doing.
Yeah, excellent. For that, and going kind of like in this same path about these transferable skills. For you, Rita, we often talk about transferable skills between geothermal and other sectors. It's something that is there in the conversations. But really, how much overlap is there in practice? And what are these most valuable skills that you have seen directly applied to geothermal from other type of industry or adjacent industries?
Okay. So a few years ago, I did a study looking at the different skills that we have in the oil and gas industry and how it applies to other industries. And it came out that geothermal had the highest correlation between the skills in the oil and gas industry amongst all the other energy resources we were dealing with. So there's definitely a huge overlap. And why is that? Is because the way the life cycle of the oil and gas industry, we go through the exploration, appraisal, development, etc. up to abandonment. We have similar stages in the life cycle of the geothermal energy resource development. The additional thing that we have with the geothermal system is we need to generate power or use the heat directly. And so once we have generated or extracted, rather, the energy from the subsurface, we need to find a way of converting it either to electricity or to use that heat directly. So there is a huge overlap in how we go to find the resource, how we're actually going to be drilling the wells, how we're going to be pulling it out, managing it, and all of that. So we see the strong overlaps in drilling engineering, the evaluation, the well log information evaluation, case tool evaluation, even the engineering and the geoscience, we see huge overlap. And then more recently, as we're going into the emerging technologies like enhanced geothermal systems, we're taking a lot of learnings from the unconventional resource development, such as hydraulic fracturing and microseismic monitoring. Now, are there areas where we could improve upon? Or yes, definitely. We may not have so much of experience with power plants, HVAC, industrial plants, but we can take learnings from other industries, especially on the mechanical side of things. And it's because, let's say, engineers, before you become a specialized petroleum engineer, you first of all learn some fundamental engineering. So some of these things become useful when you start looking at geothermal plants. Okay, safety, these are things that we do that where we see overlap. The project management and the construction. Now, what is weak is just understanding that the fluids we're dealing with are different. We're going into hotter temperatures, in which in some cases we don't even have tools that could help us to evaluate those systems. The kind of chemistry, scaling, corrosion is going to be different with geothermal systems compared to the oil and gas. So this is where we begin to see areas that are weak that we could try to improve upon. But there is a huge transferability of the skills from the oil and gas industry to that place. And one of the things I'll add is more gas industry, the mining industry, and the geothermal industry. So all of these things will come together and will be able to help us to quickly, transition or transfer skills from one industry towards the geothermal space.
Thank you, Rita. I really like that question because I think that many of us are live examples of those transferable skills. Would you like to add something,
Exactly.
Alan? Yeah.
Of course, of course. I looked at different countries around the world about the training they have, and there's some great data out there. And I have a lot of it stored away already. And it covers from A to Z. The sad part is oil and gas has done so many great things in the past, but then we got used to, I'll say in the United States, we got used to going after, say, shale. And we forgot about temperature, we forgot about depths, but we've done all this. And if I look at what's going on today in a normal geothermal well, it's just simple, it's vertical wells, and we go into a place that happens to have some water, happens to have heat, and happens to have all these things. What if all we really need is just heat? And we've got all the skills today in oil and gas to do it. It's like I have companies that tell me, well, Alan, we can't drill above 200 degrees Celsius. And you have to look at, well, what is 200 degrees Celsius? And it's 392 degrees Fahrenheit. And I said, well, Japan drilled 1998 to 500 degrees Celsius, which is 932 degrees Fahrenheit. And they did it with natural, everyday oil and gas skills. So what if we could take those skills that we already know about, apply them to the next generation of geothermal where we go? It can change everything we know about energy. I think it can be some of the cheapest energy. It's clean, and it's something we can put a lot of people jobs toward. And I think it migrates people that are already working, how we can migrate them to this opportunity.
Excellent. Good. Okay. A quick reminder to our live audience, please get your questions in the chat box for Rita and Alan. And I think that we are good on time here. So let's go with this question for both of you. It's an interesting one. So and this is before jumping into the audience questions or some final questions. So in your opinion, what emerging trend do you think will most shape the future workforce of the geothermal industry in the next 5 to 10 years? Go excited and crazy.
Can I answer this one?
Let's go, Alan. Yes.
Go ahead, Alan.
So I mentioned earlier, it's very rare to find a body of water that's below the ground that has a certain amount of heat. It has permeability and these things like that. And it turns out we're learning that those volumes are decreasing over time. And all of a sudden you could have it dry. But what if we're going toward hot, dry rock? And I mentioned this because it's exciting. And what if we apply it to oil and gas skills that we're using today across the US that's changed oil and gas, going after something that we thought we could never get it out of the ground. And this was shale and oil. And so applying these technologies is the way to go. But it means we might have to do some reservoir stimulation. In other words, breaking some cracks into the rock to send the water through it and then come out as high pressure, high temperature, and turn our turbines. This is the process. You know, I've been looking at modeling. What if I could take 6 acres, 6 small acres, and generate 50 plus megawatts of energy? Wow, that changes everything. So this is the kind of stuff that is, if we can do it right, it changes the way of energy as we know it. And geothermal, I think, can become probably one of the largest geothermal power systems we can have across the United States and across the world. This is where I think it has so much opportunity.
Great.
I'll bring a different perspective. You can see, I mean, in our lives today, people can tell me, people cannot tell me that you're not seeing the impact of AI, machine learning. And so I think that that is something that's going to be transformative in the geothermal industry moving forward in the next 5 to 10 years. Now, we are going into super hot rock, that is temperatures that are, you know, beyond the 200 and 300 degrees Celsius. We are going to be drilling deep. We're going to be finding new data. We're going to be having large amount of data. We would need to be making data-informed decisions. We're going to be modeling multi-physics phenomena, some we haven't even modeled before. So I think that these things, we're going to need the help of machine learning, artificial intelligence, autonomous systems as we go into, you know, more challenging environments. So it's going to be very, very important for us to start building skills that would help us to manage data, analyze data, make things like scaling and correlation, because we want to be more optimal. We want to improve the efficiencies. You know, converting thermal energy to electrical energy, we lose a lot of you know, we have lots of losses in that conversion. So if there's any other way we can make our systems more efficient and any methods to help us do that, we need to leverage that. You know, as we go into creating pathways, as Alan said, we're going to need to do some stimulation. We need to be able to track those pathways we're creating to make sure we are not going beyond what is safe. And you know, even seismic monitoring, we need to find ways of making sure that whatever we're doing it safe. We do not want to have any incidents in our projects that will make people lose faith in what geothermal is. You know, so I really like geothermal energy because it's versatile. So it's not just the electricity generation. There are several ways in which we could use waste heat from systems. And so all of this, we will need to be creative. And I think that artificial intelligence, machine learning, autonomous systems is really going to help us to drive the future of geothermal systems moving forward.
Thank you, Alan and Rita, for your answers. Very, very current and very realistic, really, of the situation. Yes, Alan, do you want to add something?
Yeah, this is important. It ties into what you just said. So in the last 3 months, I've had conclave meetings talking about geothermal, 22 different entities around the world, the Aramcos, the BPs, the Shells, the Chevrons. In the last 2 months, I've had the International Association of Drilling Contractors, International Association of Directional Drillers. And what the message with all this was about innovation and collaboration. And the word I really like is collaboration. Mm-hmm. And as we can bring everybody together and share, because I've had some specialists say, "Oh, Alan, we can't share this. You know, our company just," I go, "Okay, guys, stop. Okay, we're all working together. If we can start working together as a community, collaboration, this is what I think will help accelerate, and I think it will grow. But it's up to us to help drive it."
Yeah. Very important, right? Like these collaborations, like every stakeholder is really into and has a purpose for that and a role. Yeah. Okay. I think that we have time for a last question. let's take this one from the audience. Um, so this is from Brick McDowell. How can we best integrate training for these future skills into training programs? Um, yes. Rita or
Yeah,
Alan, would you like to
I could
thank
answer
you,
that, and then Alan, if he wants to add something, he could.
please?
So the thing is, we need to build upon what's already existing. So I would say certificate programs, short programs, because these are small modules that we can cover in 2 to 3 weeks and in little chunks. The skills that are needed to advance the future of geothermal systems, they are kind of varied. They are located in different places. The drilling part, the geoscience part, the engineering, the surface facilities. So we break them down into different chunks, modules, and get them out there, let them be certificate programs. But on top of it, it will be really great to have a body that, is kind of provides a framework for what the curriculum for future geothermal energy systems should be like. Somebody that says, okay, these are all the 20 or 30 courses that needs to be covered, so that people can just take little chunks out of it and focus on, okay, if I know that I'm going towards the surface facilities, I'm going to take this small course and beef up my skills, or even start up my skills in that space. Yeah, when we do it that way, people who are at zero level, they take awareness level courses. People that already have skills, they take something on the intermediate or advanced levels, and it just helps them to quickly transition to fit into what aspect of the geothermal energy space that they would fit in.
Right. For you, Alan, because I know you develop a lot of like training material, very current in what are the needs for different companies and workers. So, what is really these training programs?
And
How they
I'll
can
be
be?
honest, I'm not the one doing all the training. Imagine the training that's been developed over the last decades, brought it in. Imagine a company that has 150 plus expert consultants, and then they have all these employees. It's all focused on oil and gas. And I talked about earlier, a lot of these skills, they're there. And the beauty of this is if you're doing it right, which they are, what you can have is awareness type training, for people beginning, just to understand the beginnings of it. And it could be done all virtual and training, and it's tracked. Or it could be, from awareness, you get to trained. And all of a sudden, you're tracking that. You have learning management systems that track your progression, how you're learning or you're not. And you can do it around anywhere around the world, just about online. And this changes a lot of things. It's not everybody can afford, say, going to a university. They can't afford the travel between distances. They can't afford rental and all these things. What if we could do a lot of this online and track it and show them where their weak links are, understand what they need to do better? But all this could be and is being done already, just most people don't know this. And this is how we can apply this to schools. We can apply it to universities. We can apply it to unions. I mean, people don't realize how many unions are out there already. And there's some already starting to take this training for different things like wind and solar. Well, let's apply it to geothermal.
Excellent. Well, I think that we can go with one last question. If we can quickly address this one. This is from Jeffrey Bailey. One concern when ramping up EGS is that we don't have a long-term production histories to de-risk investment. Also, in some locations, really need to take a hard look at the geomechanical stability, seismic risk, which might also shorten the life of a project and also affect project siting. Do you have thoughts on these issues?
Yeah, so let
Very
me
quickly.
comment. Let me comment very quickly on that one. So it's a fact we don't have enough case studies to actually show this is how long the our thermal drawdown is going to be, or our production profile is going to be. And again, we don't have enough information to de-risk investments. So what I would say is a good way for us to go is to have a lot of pilot demonstration projects. Now, before we do those projects, we would have built some simulation models that tends to forecast what we see. And then if these pilot demonstration projects, we are able to match what we're seeing in those projects with what we have from the models, it then builds confidence in the models that we have. And we can use those, of course, when published, peer-reviewed, of course,
Yes,
we
right.
can use those models to then go ahead to meet people for investment. And look, these pilot projects have actually matched what we have seen in the first couple of years. Okay, and we believe that our models are correct. Or we fine-tune our models and show what we're doing. So I think that that would be helpful, but it's not something that may happen immediately because we really need data to be able to, match what we have in terms of our models.
Yes.
Alain, anything that you would like to add quickly?
No, I agree with you 100%. There's very limited data out there, but the data I have seen is spectacular. The question is how long? What's the longevity of it? And I think it really depends on the volume of rock you're accessing. So we hear about closed loop as an example. It's a tube, it wraps around, but the heat only touches the pipe. What if we send the heat out to not millions of square feet, but what if we actually talked about billions of cubic feet, billions? And I want you to hear this because you're probably going to hear me about it next year, what you're seeing. And I can't say anything more than that.
hopefully to hear more for sure. Something that we have seen about these conversations is that the collaboration and all these synergies, right, from the technical, non-technical, everything together, and everyone working together. Okay, so with this, we are going to finalize this interesting conversation. Rita and Alan, thank you very much, and the audience, to continue these collaborations toward more sustainable energy future for all of us. Now, coming up at the screen, you will see a QR code for a brief survey on today's conversation. So we will appreciate your feedback. We invite you also to visit the GEODE YouTube channel and the SPE Energy stream to watch previous conversations. And stay tuned for future GEODE conversations. Thank you very much and have a wonderful day.
And thank you, Diana.
Thank you, Diana. Thank you to all our audience.
Thank you, Rita. All right. Have a good day.
You too.